Hello, hello. Good morning. Good morning.
Mm.
Okay. So we will continue, yeah? Okay. We will continue. Last time where we left off. Okay. Yeah. So we started the topic about electricity and magnetism. Yeah. So last time we talked about um current. Yeah. What is current? Okay. So this is a big topic. So it will take some time to finish. Okay. Let's carry on. Okay. So
Mm,
last time we talked about the
Miss,
electrons. Yeah.
uh, I said in the WhatsApp, can we like do the chemistry today?
Yeah, sure. We can do chemistry also. Which topic do you want to do for chemistry? You have tests coming up.
No, I just need to like go through like revise like the previous topics, all of it.
Oh, okay. Let's see. Um, okay. Okay. All the topics that we have done so far, or all the topics that you have done in school. Yeah. If you want to do the ones that you have done in school, you can send me the topics. Yeah. For chemistry, we done until unit 9. Yeah. Okay. So we done until unit 9. So 1 to 9. Okay. So you want to have revision for 1 to 9, for unit 1 to 9?
Yeah.
Okay, can. Maybe we can do some past exam questions. Yeah, maybe we can do some past exam questions that cover all of these topics. Okay, give me a minute. Let me get the past exam papers. Okay, we can do some paper 2 and paper 4 questions. Paper 2 multiple choice. Okay, hold on. Hmm, okay, maybe we can do 1 hour of paper 2 and then 1 hour of paper 4. Okay. Mm, okay. Yep. Okay. Okay. Yeah. So this is one of the recent papers, October, November 2024. Okay. Yeah. Okay. Let's go through some questions. Um. Okay. If anything not clear, yeah, you just stop me. Okay. Okay, oxygen melts at negative 219 and boils at negative 183. At which temperature is oxygen a liquid? Yeah, okay. So we can take a look at uh the melting curve. Okay, let's say we start at negative 250. Okay, so negative 250 is still a solid, and then at negative 219 it melts. Yeah, okay. So at this step, okay, at this stage, it is liquid. Okay. Uh, liquid. Okay. And then boiling at negative 183. and then after that is gas. Okay. Yeah. So if we keep going to 0 degree here and then room temperature, so which is telling us at room temperature it is a gas, which is reasonable. We know oxygen is a gas at room temperature. So for liquid, so at which temperature is liquid? Negative 183 to negative 219. Okay, so negative 225 is here. No. Okay, negative 189 is here. Okay, so this is yes. Negative 175 is here. Okay, so it's no. Okay, 25 is here. It's not liquid. So answer is B. Okay. Next. The pressure of a sample of gas is decreased, temperature is kept constant. Okay. So temperature is constant. Okay, pressure is decreased. So when we decrease the pressure, the volume will increase. Yeah, okay. So let's say we have like something like this. Okay, temperature is constant. So we have the gas particles. Okay. So when we decrease the pressure, means volume will increase. Okay. So they are less crowded. Yeah, okay. So they are less crowded. Okay. Um okay, so movement of particles will be no change in speed because temperature is the same. So they are not moving faster or slower. Okay. No. Okay. Collision between particles occur with more force. No. Okay. More force only happen when we increase the temperature. Yeah, when we increase the temperature, it will occur with more force because the particles have more energy. The particles have more energy to collide with each other. Okay. So yeah. So this one is when temperature decrease. It will slow down. Okay. Occur with more force is when temperature increase. Okay. With more force. Okay. Collision less often. Yes. Collision less often. Why? Because it's less crowded. So the particles will collide with each other less often. Yeah. Okay. So answer is C. Okay. Okay. Rubidium has two isotopes. Okay. 37. Okay. So the 37 is proton number. Yeah. Okay. So rubidium 85, rubidium 87. Okay. So the 37 is proton number. Okay. Proton number does not change. Proton number does not change. Okay. Electron will also be the same. Number of electrons will equal the number of proton. Okay. Neutron will be equal to the mass number minus the proton number. Okay. So if I'm going too fast or too slow, you just stop me. Okay. Yeah, like this. Okay. 85 minus 37. Okay, 48. 48 and 50. Yeah, okay. They have the same number of protons. They have same chemical properties. Yeah, same chemical properties. Rubidium, if we look at the periodic table, okay. So if we open the periodic table on, yeah. Okay, if we look at periodic table, okay. Yep. Rubidium is here. Okay. Yep. Okay. Rubidium is here. Okay. So it's in group 1. Okay. So for group 1, it will form rubidium plus 1. Okay. So it has one outer electron. All the elements in group 1, they will have one outer electron. They will lose the outer electron to form the rubidium plus 1. Okay. Lithium will be plus 1, sodium plus 1, potassium plus 1, and rubidium plus 1. Okay. So they all have the same chemical properties. Why they have the same chemical properties? That is because they have um, the same electronic configuration, both isotope. Okay, so chemical properties, it depends on how many outer electrons. Yeah, okay. How many outer electrons? Okay, so the number of proton, it does not depend on the number of proton. Okay, they have the same electronic configuration. This is the main point. So when they have the same electronic configuration, they have the same number of outer electrons, they will give the same chemical properties. Okay. Different number of neutrons, no. Okay. So it only affects like things like density and boiling point. Okay. Different mass number, no. Okay. So that is the main point. Okay. Which pair of elements react to form a compound with strong attraction between oppositely charged ions? Yeah, okay. Strong attraction between oppositely charged ions like sodium, chloride, something like that. Okay. Potassium hydroxide, something like that. Okay. So, which means we have ionic compound. Okay. So ionic compounds means we have metal and non-metal. Yeah, okay. Metal and non-metal. So this one carbon, non-metal. Okay, non-metal. So this will be covalent. Okay. Carbon, nitrogen, non-metal, non-metal. So this is covalent. Okay. So sodium and potassium, metal and metal. So this one maybe it's just like metallic bonding. Okay, metallic bonding. Sodium and oxygen, yes. Metal and non-metal. So it will form ionic bonding. Okay. 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 Number 5. 4 substances PQRS described. P is diatomic. Q is a good conductor of electricity when solid and molten. Okay. So this one will be a metal. Okay. R is a silver solid with very high melting point. Okay. A S react with oxygen to form brown gas. Okay. So S, it should be nitrogen. Yeah. Okay. So brown gas is like NO2, something like that. Okay. So S should be nitrogen. Okay. Which substance are metals? Okay. Should be silver solid with very high melting point. So this is very close to characteristics of metal. So diatomic, something like O2, H2, Cl2, Br2. So these are non-metal. Okay. So metal should be Q and R. Okay. Should be Q and R. Okay. Answer is C. Okay. Which diagram shows the covalent bonding in a molecule of carbon dioxide? Yeah, okay. Covalent bonding in a molecule of carbon dioxide. Okay, so we start with carbon. Okay, so carbon is group 4. So 4 outer electron. Carbon, 4 outer electron. Okay, like this. Okay. Oxygen. Oxygen is group 6, 6 outer electrons. Okay. 6 outer electrons. Okay, so carbon need 4 electrons to get the full shell. Okay, so oxygen need 2 electrons. Okay, so which means carbon will form 4 bonds. Okay, oxygen will form 2 bonds. Okay, forming 4 bonds means it will share 4 electrons. Okay, and then oxygen will share, okay, 2 electrons. So what we end up with, okay, that both atoms will end up with 8 outer electrons will be like this. Okay, so carbon, 4 outer electrons. Okay, oxygen, okay, 6 outer electrons. Okay, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. Okay, so this is the arrangement that will end up carbon with 8 electrons in the end and oxygen with 8 electrons in the end. Okay, so we end up with this. Okay, double bond. Okay, sharing 2 electrons each. Okay, so answer will be C. Okay, yeah. So this is the arrangement that will give octet for each of carbon and oxygen. Okay, the bonding structure and melting point of sodium chloride and sulfur dichloride are shown. Okay, so sodium chloride is metal plus non-metal, so we have ionic bonding, no problem. Sulfur dichloride is non-metal plus non-metal, so we form covalent, no problem. Okay, so why does sulfur dichloride have lower melting point than sodium chloride? Yeah, okay. So sodium chloride is ions. Yeah, strong attraction between ions. Strong attraction between ions and millions of them. Okay, so millions of them attract together. So this is a very strong bond, giant lattice. Okay, so that's why it got a high melting point. Okay, so sulfur dichloride is like this. SCl2 okay, SCl2 like this. Okay, and then another one. Okay, SCl2 like this. Okay, so now this is a covalent bond, which is a strong bond. Okay, so we cannot break it easily. But this one is the intermolecular force. Yeah, okay. So intermolecular force, which is weak. Yeah, okay. So the weak bond between 2 molecules. So this one can be broken easily. So that's why it has a low low melting point. Okay. So both melting point and boiling point will be low. Okay. Yeah. Okay. Let's check one by one. Why? Okay. Sulfur dichloride, SCl2, has a lower melting point than sodium chloride. Okay. Why? Covalent bonds are weaker than attractive forces between molecules. Okay. We are saying that covalent bond is weaker. No. The covalent bond itself is strong. Okay. So covalent bond weaker. No. Okay. The covalent bonds are strong. Covalent bonds are weaker than the ionic bonds in sodium chloride. So this is also wrong. The covalent bonds, they are not weak. Okay, they are not weak. Attractive forces between molecules in sulfur dichloride are weaker than the attractive forces between molecules of sodium chloride. Okay, so yeah. So the intermolecular forces, they are weaker, yes, but they use the wrong term. Molecules is a wrong term because sodium chloride is ionic bonding. Okay, so we don't use the term molecule. Molecule is for covalent. Okay, for covalent bonding. Okay, like O2, H2O, CO2. So these are molecules. When we have ionic bonding, we don't call them molecules. So this is again incorrect. Okay. Attractive forces between molecules of sulfur dichloride. Yeah. SCl2, SCl2, SCl2. Okay. So we have weak intermolecular forces between the molecules than the ionic bonds in sodium chloride. So this is the correct reason why the sulfur dichloride they have lower melting point because these weak intermolecular forces compared to the strong ionic bonding, they are much weaker. Okay. And the melting point, during the melting point, we are breaking these intermolecular forces. We are not breaking the covalent bonding. That's why we have low melting point. Okay, next. Okay, diamond and graphite have giant covalent structure of carbon atoms. Okay, giant covalent structure. Okay, so just in case, let me just quickly open the notes to show. Okay, okay. Okay, if I'm going too fast or too slow, just let me know. Okay. Okay. Yes. Okay. Chemical bonding. Let's take a look. Okay. Yes. Okay. So diamond and graphite, we are saying that this is a giant covalent structure. Yeah. Okay. Giant covalent structure because they are, okay, 100% covalent bonding. Yeah. Okay. 100% covalent bonding. So they are very strong. Okay. Many strong bonds. Okay. So they will have a high melting point. Okay. So graphite also, they have some intermolecular forces. Okay. But still, it's mostly covalent bonding. Okay. Mostly covalent bonding. Okay. Which statement describe graphite? Okay. So this is a graphite here. Okay, so the correct description, which is this. Okay, so it has layers which can slide over each other. Yeah, okay. So it's made of layers that can slide over each other. Strong, rigid, three-dimensional structure. So this one will be diamond. Four strong covalent bond between each carbon. So this one will be diamond. Okay, so each carbon, it form four bonds. Okay, around it, each carbon form four bonds. Okay, for the graphite, each carbon is forming three bonds only. Okay, each carbon forming three bonds. Okay, no delocalized electron does not conduct electricity. So this is also diamond. Okay, so graphite, because it's only forming three bonds, it has one delocalized electron. So it can conduct electricity. Okay, next. Okay. Okay, which role explain malleability and electrical conductivity of the solid metal? Okay, we can take a quick look at the notes. Okay. Yeah, okay. Metallic bonding. Yeah, okay. So metallic bonding is like this. We have positive ions. Okay. Example, we can have sodium ions, metal sodium ions, okay, with the delocalized electrons. Okay. So why they have the uh, malleability? Because it can slide over each other. Okay, the metal ions, they can slide over each other without breaking. Okay, so we apply a force, the atoms can slide over each other, but they do not break because the delocalized electrons, they are acting as like a glue. Okay, so even when the atoms, they move over each other, the bonds do not break. Okay, so malleability. Okay, malleability means we can shape the metal into thin sheets. Okay, into thin sheets. So this is same reason. Okay, because the layers of atoms, they can move without breaking. Okay, so malleability and ductility, layers of positive ions can slide over another when force is applied. Good electrical conductivity. Why they have good electrical conductivity? Delocalized electrons, they are able to move. Yeah, okay. So the delocalized electrons, they are free to move. Okay. Okay, next. So malleability, the reason will be this. Okay. Rows of positive ions can slide over each other. Electrical conductivity. Okay. The localized electrons can move freely through the structure. Okay, this one. So answer is C. Okay. Equation for decomposition of ammonium carbonate. So we are given the equation, chemical equation. Okay, we are given the MR of the ammonium carbonate, 96. Okay, total volume of gas produced is 360 cm cube. Okay, which mass of ammonium carbonate is decomposed? Okay, so okay, let's check the ratio. Okay, ammonium carbonate. Okay, so we focus on the gas. Okay, so two gases are produced. Okay, ammonia and carbon dioxide. Okay, so two gases are produced. 1 mole of ammonium carbonate will form 2 moles of ammonia and 1 mole of carbon dioxide. Okay, yep. So now, the total gas. Okay, total gas will be 3. Okay, 2 plus 1. Okay, will be 3. So now the total gas is 360. Yeah, 360 cm cube. Okay, now we try to figure out that is so which means this is 360 divided by 3. So we got 120. So this one will be 120 cm cube and 240 cm cube. Okay, so now if we can find out how many moles of CO2, now we can find out how many moles of the ammonium carbonate. Okay, so we can find out this part here. Okay, okay, so now okay, room temperature. Okay, room temperature and pressure. We may recall room temperature and pressure. 1 mole of gas, okay, equal to 24,000 cm cube. Yeah, okay, always like this. Room temperature and pressure, 1 mole of gas equals to 24,000 cm cube. Okay, so the number of mole of the CO2 will be equal to 120 cm cube divided by 24,000 cm cube per mole. Okay, so okay, 120 divided 24,000. Okay, it is 0.005 mole. Okay, 0.005 mole. So we are saying that this is CO2, 0.005 mole. Okay, so which means ammonia is 0.01 mole. Okay, and this total is 0.015 mole. Okay, but this is not too important. Most important is we know this is 1 to 1. Okay, so if this is 0.005, which means this is also 0.005 mole. Okay, so now mass of the ammonium carbonate. Okay, mass of ammonium, okay, carbonate, okay, is equal to the number of mole, okay, multiply the MR, okay. So the mole is 0.005. The MR is 96, okay. Okay, so we get 0.48. 0.48 grams. Okay, so that's the idea. Okay. Okay, so our answer is 0.48. Okay, makes sense, huh? Okay, next. What is the empirical formula of a compound that contains 3.66 gram of hydrogen, 37.8 grams of phosphorus, and 58.5 gram of oxygen? So it's like this. Okay, H, P, and O. Okay. So actually we want to find the mole ratio. Mole equal to mass divided by MR. Okay. So the mass will be 3.66. Okay. 37.8 and 58.5. Yeah, okay. Divided by the MR. MR of hydrogen is 1. MR of oxygen is 16. How about phosphorus? Okay, MR of phosphorus here 31. Okay. Okay, we can calculate this. Okay. Okay, 1.219. 1.219. Okay. And then okay, 3.6562. Okay. 3.6562. Okay. So to make it into integer value, we can divide the small number. Okay. 1.219, 1.219. Okay. Okay. Okay, so that gives us 3. Okay, and then the other side. Okay, so this is also 3. So it's 313. Okay, so our answer is C. 3 hydrogen, 1 phosphorus, 3 oxygen. Okay. Okay, 12. Aqueous copper sulfate electrolyzed using graphite electrodes. Okay, so this one is electrolysis. Yeah, okay. So electrolysis. Okay. Okay. We have the positive electrode and negative electrode. Okay. Okay, so we have copper 2 plus. Okay, copper 2 plus will be attracted to the uh negative electrode. So we have copper sulfate. Copper sulfate, and then we have water. Okay, so we have these 4 ions. Okay, so copper 2 plus and H plus will be attracted to the negative electrode, and then the sulfate, okay, and hydroxide will be attracted to the positive electrode. Okay, so now which one will react? Which one will react? Okay, so for this part, the copper will react. Okay, the copper will react because it's lower than hydrogen in the reactivity series. Okay, so it's less reactive. So if we want one of them to react, copper will react. Okay, so copper, it will react like this. Okay, Cu 2 plus 2 electron turn to copper metal. Okay, so this is a reduction. Okay, and then this will be oxidation. Okay, oxidation is always anode. Okay, reduction is always cathode. Okay, so cathode, it will be copper. Okay, oxygen, no. Okay, so electrode turns pink, correct, because we form the copper metal. Okay, electrode turns pink. Okay, how about anode? Okay, anode, we have sulfate and hydroxide. Hydroxide will react because sulfate is very stable. Okay, so usually sulfate does not react. So hydroxide react, it will form oxygen. Okay, so the complete equation, we don't need to know. We just need to know the hydroxide will turn to oxygen. Okay, so the product will be oxygen. Okay, so this is no. Okay, so we will form bubbles of gas. Okay, so we'll form bubbles of gas, no problem. Bubbles of gas and electrode dissolve, no. Okay, so the electrode is the inert graphite electrode, so it does not dissolve. Okay, so answer will be A. Okay, next. Okay, molten sodium chloride electrolytes using inert electrodes. Okay, so molten. So molten means no water. Yeah, we just melt it. Okay. 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 So we have sodium ion and chloride ion. Okay. No water. So sodium will be attracted to here. Chloride attracted to the positive electron. Okay. So now sodium will be reduced. Okay. Plus electron turns to sodium metal. Okay. Turns to sodium metal. Return back to sodium metal. So this is a reduction. Okay, so reduction is always cathode. Okay, so which means this is oxidation and this is anode. Okay, what happened to chloride? Okay, so you see this one, it plus electron. So chloride will minus the electron to form, okay, two of them to form the chlorine gas. Okay, so normally the electron, we don't put minus, we always put plus. Okay, so the chloride will turn to chlorine gas plus 2 electrons like this. Okay, so the product for the cathode product will be sodium metal. Yeah, okay, cathode will be sodium metal. Yes. Okay. Okay, so no, no, no. Okay, so anode, the product will be chlorine gas. Okay. Yep. So answer is D. Okay. Okay, equation for the formation of ammonia. Okay, no problem. So we can see this is exothermic reaction. Okay, exothermic reaction. Okay. What is the enthalpy change for the reaction? Okay. So enthalpy change for the reaction. Okay, it's this part here, enthalpy change of reaction. Okay, so which means we take this one minus this one, it will give us this one. Okay, so yeah, so enthalpy change is, because this is exothermic reaction, so we know that it will be negative. Yeah, so it will be negative. Okay, negative 342. Okay, so we don't concern about the sign. We just want to know this number. Okay, so this number is 342 minus 250. Okay, 342 minus 250. Okay, 92. And we know that this is exothermic reaction, so it will be negative. Okay, negative 92. So this is the answer here. Okay, next. Okay. Okay, sulfur dioxide convert to sulfur trioxide in the contact process. Okay, so we did learn about this. Okay, conditions 450 degrees Celsius and 200 kilopascal with vanadium oxide catalyst, no problem. Okay, which row describe and explain the effect of changing conditions on the rate of reaction? Okay, so rate of reaction. So we can take a look one by one. Okay. Okay, which one explain the effect of the condition on the rate of reaction? Okay, so okay, so if we lower the pressure, okay, lower the pressure means the particles, they are less crowded. Okay, the particles, they are less crowded, so they will collide. Collision will be less. Okay, because they are less crowded, they don't meet each other easily. Okay, so they will be less crowded, less collision, so rate of reaction will decrease. The rate will decrease. So this is no. Okay, more particles per unit. No. Okay, lower temperature. Okay, lower temperature, if we decrease the temperature, okay, we will slow down the reaction. Yes. Okay, so the reaction will slow down. Why? Because the particles, they have less energy. Okay, the particles have less energy, so they will collide. Collision will be less. Okay, collision will be less. So this one, they say collision is more. This is wrong. Okay, this is wrong. Okay, when we increase the pressure, okay, the rate will be higher. Yes. Okay, rate will be higher because the particles, they are more crowded. Okay, so they are more crowded, they will collide more. Yeah. Okay, so they will collide more, they have a higher rate. Okay, so particles have more kinetic energy. No. Okay, so they are not moving faster, they are just more crowded together. Okay, so it's kind of like this. Okay, so like similar to what we mentioned just now. Okay, so at first it's like this. Okay, so when we increase the pressure like this, okay, okay, so they become more crowded. Okay, so more crowded, they will collide more. Okay, so the rate will increase. Okay, but the temperature does not change. So they collide more is not because they have more energy. It's because they are more crowded. Okay, so this is no. Okay, answer is A. So when we have no catalyst, the reaction will slow down because the activation energy is higher. Okay, let us quickly refer to the notes. Okay, um, okay, let us quickly refer to the notes. So this one is about the rate of reaction. And on. Okay, it should be this one. Okay, so what is the thing that increase the rate of reaction? Yeah, okay. Yep. Okay, so just now we were talking about the catalyst. Okay. So without catalyst, the activation energy is high. Okay. So activation energy is high. So the reaction is slow. Okay. So when we add the catalyst, the activation energy is decreased. Yeah, okay. So activation energy is decreased. So more of the particles can start to react. Okay, more particles can start to react. So reaction speed up. Okay, faster the reaction. Okay. Yes. So that's why no catalyst, the rate is lower because activation energy is higher. Okay. Okay, hydrogen gas react with iodine to form hydrogen iodide gas in equilibrium reaction. Okay, so we also learn about this equilibrium. Okay, which changes increase the yield? Okay, so we just want to increase the yield. Okay, so how many percent of product produce? Okay, so let's say for this equilibrium we produce 20% of product. Okay, so only 20% react. But if we want to increase the yield, example, we increase to 50%. Okay, so that is increasing the yield. Okay, so adding catalyst, no. Okay, adding catalyst, it only speed up the reaction, but it does not increase the yield. Okay, so adding catalyst does not increase the yield, only speed up the reaction. Okay, so one is no. Okay, adding more hydrogen gas. Okay, adding more hydrogen gas. Yes. So when hydrogen gas it increase, it will push the reaction to the right. Yeah. Okay. Because the hydrogen will react more when we have more hydrogen. So it will push the reaction to the right hand side. Okay. So this product will increase. Okay. The yield will increase. Yes. Okay. Increasing the pressure. Okay. Increasing the pressure. Okay, let's see. So left hand side. Um, okay. Left hand side, we have 2 mole of gas. 1 plus 1. Okay. Right hand side, we also have 2 mole of gas. Okay. So when we have same mole of gas, left and right, same mole of gas, when we increase the pressure, will be no change. Yeah, okay. So when both sides have same mole of gas, when we increase the pressure, there will be no change. So no effect. Okay. Increasing the pressure, increasing the temperature. Okay. Okay. Increasing the temperature, when we increase the temperature, the equilibrium will try to decrease the temperature. Okay. So when it tries to decrease the temperature, it will go to endothermic reaction. Yeah, it will go to endothermic reaction, which will absorb energy. Okay, endothermic reaction will absorb energy. Okay, so in this case, the endothermic reaction is the forward reaction. Okay, endothermic is the forward reaction. So forward reaction, it will produce more product. So in this case, the yield will be increasing. The yield will be increasing. Okay, so answer is 2 and 4. Okay. Okay, next question. Okay, equation for the reaction of carbon with carbon dioxide is shown. Okay, which row identify the carbon atom that is reduced and change in oxidation number? Okay. Okay. So we start with this carbon, okay? So this carbon is elements, okay? Before we do anything, okay? It's element. So whenever element, the oxidation number is 0. Yeah, okay? So oxidation number is 0. Okay. So this one is 0. How about this one? CO2. Okay. So CO2. Okay, so this is covalent compound. So the overall is equal to 0. Oxidation number is equal to 0. So carbon plus 2 oxygen. Oxygen is always -2. Okay. Oxygen is always -2. This is equal to 0. Overall is 0. C minus 4 equals to 0. C equals to plus 4. Okay. So this one, the oxidation number is plus 4. Okay. And then CO. Okay. CO again overall is 0. Okay. And then carbon plus oxygen is -2. So which means carbon is plus 2. Okay. Plus 2. Okay. So from carbon to CO is from 0 to plus 2. This is a oxidation. Okay. This is oxidation. Okay. How about from CO2 to CO? Okay. CO2 to CO is from plus 4 to plus 2. This is a reduction. Okay. So this is a reduction. So we want reduction. Okay. Reduction means this one, CO2 to CO. Okay. CO2 to CO is from plus 4 to plus 2. Okay. This one. So our answer is B. Okay. Okay. Next, 18. Okay. Aqueous iron sulfate added to acidified potassium manganate. Okay. Purple color disappear. Potassium manganate is oxidizing agent. Oxidizing agent. Okay. Yep. So, which means the iron sulfate will be reducing agent. Okay. So they are always opposite to each other. Okay. Aqueous potassium iodide is added to acidified potassium dichromate. A dark brown solution is formed. Okay. So potassium dichromate, it is also oxidizing agent also. Okay. Which means potassium iodide will be reducing agent. Okay. Dark brown solution form. So the dark brown solution is the iodide. It turns to iodine. Okay. So that's the dark brown solution. Okay. Which row identify the iron sulfate and potassium dichromate? Okay. Potassium dichromate is oxidizing agent. Okay. Iron sulfate will be reducing agent. Okay. So answer is D. Okay. Yep. Okay. 19. Okay. Which row show the difference between weak acid and strong acid? So, hold on. I think we already done this one. Yeah. Acid, bases, and salts. We done that. Okay. So, okay, let's see. Weak and strong acid. Okay. So, weak acid will be partially dissociated. Yeah. Partially dissociated. And then strong acid is fully dissociated. Okay. Yeah. So partially dissociated means, okay, example, ethanoic acid. Okay. CH3 COOH. Okay. So CH3 COOH, it will lose the hydrogen CH3 COO, and then hydrogen. Okay. Fully dissociated, for example, HCl, it turns to H plus and Cl negative. Okay. So strong acid, it fully dissociated. So means it will produce more. Okay. The hydrogen ion. This one partially dissociated, it will produce less. Okay. So that's the idea. Weak acid and strong acid. Okay. Which substance turn metal orange red? Okay. Turns metal orange red. Okay. So we can quickly refer. When metal orange is red, what is the situation? Okay. And okay, let's take a look. Metal orange. Ah, yes, here. Okay. Metal orange is red when it is acidic. Okay. Neutral is orange, yellow, alkaline. Okay. So red is acidic. Okay. Acidic. Okay. Ammonia is alkaline. Okay. Hydrochloric acid is acidic. Okay. Sodium hydroxide, alkaline. Okay. Distilled water, neutral. Okay. So no, no, no. Okay. Answer is acidic. Okay. Next. Which role best describe zinc oxide and calcium oxide? Okay. This one, um, okay, um, I think we have done it. I think we have done it. Okay, let's see. Okay. Eh, maybe here. Okay, hold on. Okay. Um, okay. Okay. Um, okay, let me find from another sets of notes. Okay. Mm, okay. Should be here. Okay. No. Ah, here. Okay. So different type of oxide. Okay. So if we have metal plus oxygen, we will form metal oxide. Okay. Non-metal plus oxygen will form non-metal oxide. Okay. So metal oxide, we have basic and amphoteric. Okay. Non-metal oxide, we have acidic and neutral. Okay. So neutral, example, COH2O. This is neutral non-metal oxide. Acidic, okay, will be things like CO2, NO2, SiO2, SO2, SO3. Okay. So any non-metal plus oxygen, okay, will form acidic oxide. Okay. So if we add water, it will form acid. Okay, so this is acetic oxide. Okay, it can react with bases to form salt and water. Okay, and okay, metallic oxide, we have basic. Okay, basic means like sodium oxide, calcium oxide, magnesium oxide. Okay, what happened? If it is soluble in water, it will turn to alkali. Okay, like sodium hydroxide. Okay, and then because it's basic, it can react with acid to form salt and water. Okay, and then another one, amphoteric. Okay, amphoteric is very special. Special means it can react with both acid and base. It can react with both. So that's what we mean by amphoteric. Example, aluminum oxide, lead oxide, and zinc oxide. Okay. Yep. Coming back to our question. Zinc oxide. So zinc oxide just now we saw is amphoteric. Okay. Calcium oxide. Okay. Calcium oxide is basic. Okay. Basic. And okay. So answer is D. Okay. Okay. Next. Which row show the properties of transition element? Yeah. Okay. So we have learned about this. Transition elements. We have learned. It's under the periodic table. Okay. So transition elements. Wait. Okay, characteristics of the transition elements. Okay. Yep. Okay. So in the middle part of the periodic table, okay, the characteristics, physical properties, high melting point, high density, chemical properties, form colored compounds, and have catalytic activity. Another one, they have variable oxidation state. Okay, so means they can have more than one oxidation state. Okay. Um. Okay. Properties of transition elements, catalysts. Yes, they can act as catalysts. Okay. Electrical conductivity, good, because they are metal. Okay. So color of oxide, so they can form color oxide. They can form color. So, yes, color will be yes, no problem. Okay. So the rest will be no. Okay. So our answer is A. Okay. Our answer is A. Okay. Next. Um. Okay. Fluorine is group 7. Yeah. So again, this is a periodic table question. Okay. Fluorine is group 7. Okay. Which statement describe fluorine? Okay. A monoatomic, no. Fluorine is F2. Okay. Um, okay, what else? Okay. Inert, no, it can react. Okay. So because it has 7 outer electron, okay, 7 outer electron, it can react, no problem. Okay. Solid at room temperature, no, it is a gas. Okay. So it is a gas at room temperature. So a fluorine. Yes. Um, yep. Okay. Fluorine is a yellow gas at room temperature. Okay. Solid at room temperature. No. Okay. Non-metallic. Yes, it is a non-metal. Okay. Next. A. Okay. So up to here. Okay. Done. Because we learn until unit 9. Okay. We learn until unit 9. In the exam paper, pretty much we can do the questions until 24. So the rest will be not related. Okay, so we haven't learned yet. Okay, so we haven't learned yet. So we'll be until here. Okay. All right. Next, maybe we can try to do some paper 4 questions. Okay, we can try some paper 4 questions. Okay, hold on. Okay, let me get some paper 4 questions. Yeah, so for today, I'm just going through different questions from different topic. So if you feel like any particular topic you want me to go through, we can do it. Okay, and also uh any particular topic we can go through. Yeah. Or if you want to go back to watch the video, you can also do so. Okay, paper 4. Let me find some related questions. Okay. Okay. Um, okay, maybe we can try this. Okay. Okay, so this is one of the recent papers, May, June 2023, paper 42. Okay, let's take a look. Okay, so this one. Okay, so we need to match this, okay, oxide to the description. Okay, let's try to do that. Okay, match the oxide to the descriptions. Okay. Yep. Okay. One. Okay. So responsible for acid rain. Okay. So which one will be responsible for acid rain? So it will be sulfur dioxide. Okay. Sulfur dioxide because it is acidic oxide. Just now we mentioned non-metal plus non-metal will form acidic oxide. So when it react with water, it will form acid. Okay. So it can form acid rain. Okay. So answer is D. Okay, giant covalent structure. Okay, giant covalent structure. It will be silicon oxide. Yeah, silicon oxide. So just now we mentioned hold on. Yes. Okay, so just now we mentioned diamond and graphite. They are giant covalent structure. Okay, so we also have another one. Yeah, silicon dioxide. This is also giant covalent structure. Okay. Yeah, because it forms a 100% covalent bonds. Okay, all of them covalent bonds, very strong bonding. Okay, so this answer will be silicon dioxide. So this will be C. Okay, reducing agent in the blast furnace. Okay, reducing agent in the blast furnace. Okay, so this one, the blast furnace. Okay, maybe this one we not yet learn. Okay, so the blast furnace is to reduce iron 3 plus to iron metal. Yeah, okay. So this one is reduce. Okay, so we need a reducing agent. So this one, usually we use the carbon monoxide. Okay, so carbon monoxide can be oxidized to carbon dioxide. So the reducing agent will be carbon monoxide. Okay. Okay, main constituent of bauxite. Okay, so bauxite, we may recall. Okay, let me open the topic. Okay, Um, okay, this one. Okay. Yep. Okay. What is bauxite? Okay. So bauxite is actually um aluminium oxide. Yeah. Okay. So bauxite is actually impure aluminum oxide. Okay. So it's kind of look like this. Okay. So from bauxite, we can get aluminum oxide. And then from aluminum oxide, we can get aluminum. Okay. So aluminum oxide is not useful. It's just like rocks. Okay. It's not really useful. But when we reduce it back to aluminum metal, so the metal itself is useful. Okay. So we want to do that. So that is the important part. So how do we do it? Okay, we do it by electrolysis. Yeah, okay. So later, if we have time, we can go through again. We do it by electrolysis. Okay. Yeah. Main constituent of bauxite is aluminum oxide. Yeah. Okay. Aluminum oxide answer is B. Okay. Yep. So this is the type of questions that can come up in the exam. Okay. So iron ore. Okay, how about iron ore? So just now, bauxite is the aluminum ore is Al2O3. Okay, so iron ore will be Fe2O3. Okay, will be iron oxide. Okay, so and then from iron oxide, we will get the iron metal, which is useful. Okay, iron oxide is not useful. Okay, okay, C. Wait. Um, sorry, my mistake. Iron ore is the iron oxide impurity. Okay, impurity in the iron ore, it is the silicon dioxide. Okay, let me quickly show in the notes. And it should be somewhere here. Ah, yes. Okay, extraction of iron. Yeah, okay. So if we want to get iron from iron oxide, we need to go through this process, okay, inside the blast furnace, okay, and then this, okay, the ore of the iron is called hematite. Inside is mainly iron oxide, okay, inside is mainly iron oxide, but it got some impurities. Yeah, okay. Main impurity of the iron ore will be the silicon dioxide. Yeah, okay. So that's the one. So how we remove this silicon dioxide? We add the limestone. Okay. So the limestone help us to remove the silicon dioxide. So it will form the limestone will form calcium oxide. It will break down to form calcium oxide. Calcium oxide react with the silicon dioxide to form this um calcium silicate. Okay. So this is a molten slag, which will be a separate layer. Okay. So this slag will be separate layer. We can separate from the molten iron. Okay. So that's the one. And yep. So should be silicon dioxide can be reduced by heating with copper. Okay. Can be reduced by heating with copper. Okay. So copper is like this copper metal. Okay. Oxidize. Okay. So what is the thing that can be reduced? Okay. Our answer is silver oxide. Okay. So this one we haven't learned yet. This one we will learn later. Okay. So because copper is higher than silver in the reactivity series. Okay. So let me just show you. Let me just show one important concept. Okay. Which is this. Yeah. Okay. This reactivity series. Okay. And yep. Reactivity series. Okay. So copper is here, silver is here. Okay. Reactivity series, the more we go up is more reactive. Okay. More reactive. The more we go down, less reactive. Okay. More reactive means they want to turn to ion. Like potassium, it wants to turn to ion. Sodium, it wants to turn to ion. But less reactive, like gold, it wants to stay as metal. Okay, like silver, it wants to stay as metal. Okay, so example, when we mix two together like copper and silver, so copper is more reactive, so it wants to become ion, and then silver wants to turn to metal. Okay, so that's the idea. Going back to our question, copper is more reactive, so it wants to go to ion. Silver, okay, silver oxide, okay, silver ion, it wants to return back to metal. Okay, so that's the idea. So this one we will learn in more detail later. Okay, next. Okay, fluorine, chlorine, bromine, group 7 of the periodic table. Okay, state the name given to the group 7 elements. Group 7, we know group 7, we call them halogen. Yeah, okay. Okay, why group 7 elements? They have similar chemical properties. Okay, why they have similar chemical properties? Because they all have the same number of outer electrons. They all have 7 outer electrons. Yeah, when they have the same number of electrons, outer electrons, they will have the same chemical properties. Okay. Yep. Same number of outer shell electrons. Okay. Next. Color and state of group 7 elements. Yeah, we know that. We know that. Just now we mentioned. Okay. Uh, yes. Okay. Fluorine is gas. Chlorine, green gas. Bromine, brown liquid. Iodine, purple solid. Okay. Yep. Okay. Like this. Okay. Fluorine, pale yellow gas. Chlorine, pale yellow green gas. Bromine, red brown liquid. Okay. So you can see the exam questions, they are not too difficult. Okay. They are not too difficult. Just some of the things we need to memorize. Okay. Bromine has two naturally occurring isotopes. State the term given to the number 79 and 81. Okay. So if we look at bromine, hold on. Okay. It's bromine. Yeah. Okay. This is bromine. Yeah. Okay. Okay. Bromine. Hold on. Yeah. Okay. So if we look at the periodic table, this is the number of proton. Okay. So this is the mass number. Okay. So this is the mass number, but this one is the average. Yeah. Okay. So this is the average mass. This one is, okay, bromine 79, bromine 81. And then we will calculate this one, like how many percent? Like this one bromine is like 50%, and then this one is 50%. Then overall, the average, okay, the average of the bromine, it will be 80. Yeah, okay. So this is the average mass, okay. But in reality, we have two types of bromine, okay. We have two types of bromine. So the number 79 and 81, they are the mass number or nuclear number, okay. Next. Okay, so if we have bromine 79, okay, so the proton number is 35, okay. So proton number is always the same. It does not change because the proton numbers, they are inside the nucleus, okay. They cannot move. They are inside the nucleus. They cannot move. So it does not change. Okay, so proton is always the same. Okay. So neutron. Okay, neutron will be mass number minus proton number. Okay. So mass number minus proton number, mass number minus proton number. Okay. So that should give us 44. Okay. And 46. Okay. So the difference is on the neutrons. Protons, no change. Okay. So now this one is just neutral. Okay. So when it's neutral, electron will be equal to proton. Okay. Which is equal to 35. Okay. 35. Yep. Like this. Okay. Okay, next. This one is negative 1, the charge. Okay. Negative 1 charge means electron will be 36, proton will be 35. Okay. Negative 36, positive 35 will be negative 1. Okay. So which means we have extra electron. Okay. Yep. Okay. So that's the idea. Okay. Carry on. Okay. And then this one. Table shows relative abundance of two naturally occurring isotopes of bromine. Okay. So which means, okay, so let's say we take like 100 grams of bromine, we will find 55 grams of bromine 79, okay, 45 grams of bromine 81. Yeah, okay. So two types of bromine. So that's the idea. Okay. So we want to calculate relative atomic mass. Okay. Relative atomic mass means the average. Okay. So we want to calculate this. Okay. So basically, okay. Essentially, we want to calculate this number. Okay. We want to calculate the average. Actually, we already have the answer, which is 80. We already have the answer, but we need to show the working, how we do it. Okay. So let's say we don't know this answer, how we do it. Okay. So how we calculate the average, we take 79 is made out of 55% plus 81 is made out of 45%. Okay. So like this. So this is how we calculate the average. Okay. So if we done everything correctly, we will get 79.9. Okay. So 79.9, which is similar to 80%. I mean 80. So that's the idea. Okay. Okay, next. Okay, chlorine displaces bromine from aqueous potassium bromide, but does not displace fluorine from aqueous sodium fluoride. Okay. Write the symbol equation for the reaction between chlorine and potassium bromide. Okay, chlorine, potassium bromide. Okay, this one we last time we mentioned about it. I'm not sure you still remember or not. Okay. This one for the group 7 halogen. Okay. Yes. Okay. Halogen displacement reaction. Okay. So which one is most reactive? Okay, so we have fluorine, chlorine, bromine. Okay. So fluorine will be most reactive. Bromine will be least reactive. Okay. So the most reactive one, it will prefer to become the ion. Okay. So it will turn to ion. Okay. So this one, this reactive, it will remain as the atom. Okay. Atom. Okay. So this one, when it form the ion, it will form the octet once it's formed the ion. But this one, the atom is still the 7 outer electrons. Okay. So that's the difference. The most reactive one, it will prefer to become the ion. Okay. So now, okay, coming back to our question. Okay, so we have chlorine and bromine. Chlorine, chlorine, bromine. Okay. So this is more reactive. Okay. So this is less reactive. Okay. So the more reactive, it will turn to ion. So chlorine is higher than bromine. So chlorine is more reactive. So the chlorine, it will turn to the um, chloride ion. Okay, like this. Okay, it will turn to the chloride ion. Okay, but the bromide, it will return back. Okay, a bromide ion, it will return back to the bromine gas, like this. Okay, symbol equation. Okay, so it will look like this. Okay, so this one is the full equation. Okay, chlorine plus the KBr. Okay, so the KBr is K plus, okay, bromide negative, and then K plus Cl. Okay, so this one, how we balance this equation? We remove the electrons. Okay, so if we balance the equation, we will get Cl2, 2Br negative, and then 2Cl negative plus Br2. Okay, so this is essentially it is the same, just that this one we don't include the potassium because the potassium it got no change. It's the spectator ion. So for this one, the ionic equation we don't include. But for the full equation, we will include the potassium. Okay, so it looks like this. Okay, why chlorine does not displace fluorine? Okay, so now if we mix chlorine and fluorine together, fluorine is more reactive. Okay, so when it is more reactive, it cannot be displaced. Okay, only the more reactive one can displace. Okay, chlorine is less reactive than fluorine, so it cannot displace fluorine. Okay. Okay, aqueous silver nitrate is colorless solution containing silver ions. Okay. What is seen when silver nitrate is added to sodium chloride? Okay, silver nitrate plus sodium chloride. Okay, what is seen when, sorry. Okay, silver nitrate. Okay, so essentially, the silver and the chloride will react. Okay, so this is a white precipitate. Okay, and then we have the sodium nitrate. Okay, so what we expect to see, white precipitate. Okay, ionic equation including state symbol. Okay, so you see, this one, everything is aqueous. Okay, everything is aqueous. Okay, so this is a solid precipitate and then this is aqueous. Okay, so if we show all of the ion, Ag plus, nitrate negative, sodium plus, chloride negative, okay, and then it forms silver chloride solid plus sodium plus and then nitrate. Okay, so we can see the spectator ions, they have no change. Okay, no change. So we are left with the aqueous silver plus the chloride aqueous. It turns to the silver chloride solid. Okay, so that's the ionic equation. We remove the spectator ions. Okay, next. Okay, so some of the topics we haven't learned yet, so we will skip. Yeah, we'll skip a bit. Okay, this one is about equilibrium. So this one we also already learned. Okay, so this one, forward reaction is exothermic. Okay, delta H is negative. Okay, so forward is exothermic. Okay, so meaning the backward reaction is endothermic. Okay. Okay. Now we will take a look at the conditions. Okay. So when we change the conditions, what happened? Okay. So rate of reaction. Okay. The other one is the equilibrium. Okay. So this one, the product of the SO3 product. Okay. So we'll look at it one by one. Okay. Okay. So we focus on the rate of reaction first. Okay. So when we decrease temperature, the rate will always decrease, always, because the particles have less energy. Okay. Increase pressure. Okay. So when we increase the pressure, what happens? Okay. When we increase the pressure, the rate will increase. Why? Because the particles, they are more crowded together. Okay. They are more crowded together. So they can collide more frequently. Okay. So this is increase. Okay. No catalyst. Okay. So when we have no catalyst, the rate will decrease. Because for no catalyst, the activation energy is higher. Okay. So when we have a catalyst, we have a lower activation energy, then the rate will increase. Okay. Now, equilibrium. Okay. Equilibrium is telling us how many percent of product is formed. Okay. So let's say we form 20% of product. If we push the equilibrium to the right, okay, we can increase the product, for example, to 50%. Okay. So now, first thing we will mention, catalyst has no effect on the equilibrium. Okay. So catalyst has no effect, no change. Okay, because catalyst, it only change the speed of the reaction. Okay, so it only change how fast the reaction. So let's say we will form 20% of the product. We just get there faster. Okay, but we still get 20%. If we supposed to get 50%, we just get there faster. It's still 50%. Okay, so first we must remember catalyst, it only affect the how fast the reaction, but the how much product, no effect. Okay, how about temperature decrease? Okay, so if we decrease the temperature, the equilibrium will try to increase the temperature. Okay, so when it try to increase the temperature, it will go to the exothermic reaction. So it will go to the exothermic reaction because exothermic reaction will release energy. Okay, so it will go to the exothermic reaction. The forward reaction is exothermic. So it will go to the forward reaction. It will form more product. Okay, so the yield will increase. Okay, yep. Okay, how about if we increase the pressure? Okay, so left hand side is 3 mole of gas. Okay, right hand side, this is 2 mole. Okay, so if we increase the pressure, the equilibrium, it will try to decrease the pressure. Okay, equilibrium try to decrease the pressure, so it will go to the side with less mole. Okay, so it will go to less mole. Less mole is the right hand side. Okay, so it will favor forward reaction. So forward reaction, it will produce more product. Okay, so the yield will increase. Okay, yeah. Okay, next. Explain in terms of collision theory. Okay, why reducing the temperature decrease the rate of the forward reaction. Yeah, okay. So when we decrease the temperature, the particles, okay, they have less energy. Okay, so they have less energy, they will collide less frequently. Okay, less frequently and less force. Okay, so that's why the rate of reaction will decrease. Okay. Okay, so to get the full marks, we need to give these points. Okay, kinetic energy of particles decrease, frequency of collision between particles decrease, and then yes, so lower percentage, okay, of the particles, they have energy greater than the activation energy. Okay, or fewer of the collision have energy greater than the activation energy. So the rate of reaction will decrease. Okay. Okay, next. Sulfuric acid contains SO4 2 negative ion. Oxidation number of oxygen is -2. Okay. Calculate the oxidation number of sulfur. Okay. So we know this SO4, okay, overall, the oxidation number is -2 overall. Okay. Sulfur, we don't know, but oxygen, we know that is -2. Okay. S minus 8 equals to -2. Okay. S equal to 8 minus 2. Okay. Equal to +6. So this is how we calculate the oxidation number of sulfur. Okay. So oxidation number of sulfur is 6. Okay. Okay. So this topic also we already done. Okay. So this is a acid-base reaction. Okay. Sodium hydroxide dissolve in water to form aqueous solution. Okay, no problem. What it means by the term base. Okay. We may recall from the notes. Base means proton acceptor. Okay. Okay. Acid will be proton donator. Okay. Acid will donate the electron. The base will accept the acid will donate the proton. Okay. The base will accept the proton. So the proton is just the H plus ion. Okay. The term given to a base which dissolve to form aqueous solution. So when a base can dissolve in water to form aqueous solution, we call it alkali. Okay. Okay. Color of thymoltalin in sodium hydroxide. Okay. Color of thymoltalin in sodium hydroxide. Okay. Thymoltalin. Okay. This one. Okay. Thymoltalin, acidic, is colorless, neutral, pale blue, alkaline is blue. Okay, so back to our question. This one is alkaline, so it should be blue. Okay. Okay, complete the word equation. Reaction between sodium hydroxide and ammonium chloride. Okay. So sodium hydroxide, okay, ammonium chloride. Okay. So what actually happened? Sodium and chloride, it will form the sodium chloride salts. Okay. So that is the first step. Okay. Okay, now this one, the ammonium, what happened is it will react like this. Yes, NH3 and H plus. Okay, so the NH3 will be the ammonia. Okay, here. Okay, and hydroxide and the proton will combine together to form water. Okay. Yep. Okay, some metal oxides react with sodium hydroxide. Sodium hydroxide is alkaline, means this will be acidic. Yeah, okay. So state the term given to metal oxide which react with bases such as sodium hydroxide. Okay, so this will be acidic. Oh, okay. Sorry, my mistake. Okay, so this is metal oxide. Okay, so just now we mentioned metal oxide. We have two types. Hold on. Yes. Okay, metal oxide. We have two types. Okay, if non-metal oxide, we have acidic and neutral. Metal oxide, we have basic and amphoteric. Okay, so if we want to uh, react with bases, means we have amphoteric because amphoteric can react with both. Okay, amphoteric can react with both. If we want the metal oxide to react with bases, means we have amphoteric. Okay. Yep. Okay. Amphoteric oxide. Name a metal oxide that react with sodium hydroxide. Okay. Example. Amphoteric oxide. Here. Aluminium oxide, lead oxide, zinc oxide. Okay. Yep. Okay. Both acceptable answers. Okay. Next. Okay. So next we will be this is more of organic chemistry, but actually we already learned dot and cross diagram. Okay, dot and cross diagram of ethanoic acid. Okay, so it will be like this. Yeah. Okay, so we need to make sure we do everything correctly. Okay, so carbon, it will be starting with um 4 outer electrons. Okay, carbon will be 4 outer electrons, and then hydrogen 1. Okay, in the end we form the full shell. Okay, so this is another carbon, is 4 outer electron. Okay, 4 outer electron, and then it forms, okay, 1, 2, 3, 4. Okay, form 4 bonds. Yep, so it's still full shell. Okay, oxygen is 6 outer electron. 1, 2, 3, 4, 5, 6. Okay, form 2 bonds with hydrogen and oxygen and carbon. And then this one, oxygen, also the same. 6 outer electrons form 2 bonds with the carbon. Okay, So if we sketch everything, it will be like this. Okay. Yes. Okay. Single bond sharing one pair of electrons. Double bond sharing two pair of electrons. Okay. Okay. pH of dilute ethanoic acid. Okay. So we know ethanoic acid is a weak acid. Okay. So if it is a weak acid, the pH will be like around 3 to 7. Okay. Yeah, so that is for the weak acid. Symbol equation, dissociation of ethanoic acid. Okay, so it will dissociate to give the proton ion. Okay, the hydrogen ion. Okay, but we have the reversible reaction there because it's only partial dissociation because it is a weak acid. Okay, ionic equation when acid neutralizes a soluble base. Okay, so soluble base example sodium hydroxide. Okay, so now we have this um when N acid neutralize a soluble base. Okay, so let's say we have HCl plus sodium hydroxide. Okay, so we'll form sodium chloride plus water. Okay, so this is aqueous, 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 liquid. Okay, so for the aqueous, we can show all of the ions. Okay, we'll show all of the ions. H plus Cl negative, sodium plus hydroxide negative. Okay, and then sodium plus chloride negative plus water, which is a liquid. Okay, so now we will remove the spectator ions. No change. Okay, and then chloride also no change. Okay, so we are left with H plus aqueous hydroxide aqueous turns to water liquid. Okay, so this is what we mean by ionic equation. We remove the spectator ions. Okay. Okay. Next. Okay, so this is a calculation question. Okay, let's take a look. In a titration, 25 cm³ or 0.8 mol dm³ of aqueous potassium hydroxide neutralized by 20 cm³ of dilute sulfuric acid. Okay, so it's kind of like this. Okay, so we have this potassium hydroxide, KOH. Okay, like this. Okay, KOH 25 cm³, okay, 0.8 mol per dm³. Okay, and then we titrate with the okay, titrate with sulfuric acid. Okay, 20 cm³. Okay, so this one, concentration, this is the one we need to calculate. Yeah, okay. So concentration, mole per dm³, we don't know. Okay, so that's the idea. Okay, next. So we can do it step by step. Okay, so first step, calculate number of moles of KOH. Okay, so we know concentration equals to mole divided by volume. Yeah, okay, mole per dm³. Concentration equal to mole divided by volume. Okay, so mole will be equal to the concentration multiply the volume. Okay, so concentration is 0.8. 0.8 mole per dm³. Okay, so now we need to change the unit because this is 25 cm³. 1 dm cube equals to 1000 cm cube. Okay, 25 cm cube. Okay, so we change the unit. Okay, so cancel. Okay, so we get the unit that we want, which is mole. Okay, so 0.8 divide 1000 multiply 25. Okay, so if we calculate that correctly, we will get this one. Okay, 0.002 mole. Okay, 0.002 mole. Determine the number of moles of sulfuric acid that react with the potassium hydroxide. Okay, so what is the ratio? KOH and sulfuric acid. Okay, so we can see here 2 KOH versus 1 sulfuric acid. 2 to 1. Okay, so now KOH is just now 0.002. So which means sulfuric acid is 0.001. Okay, 0.001 more. Okay, so that is the next answer. Okay, next. Calculate the concentration of the sulfuric acid in mole per dm cube. Okay, so concentration equals to mole divided by volume. Okay, so now we already have this. The mole is 0.001 mole. The volume, the sulfuric acid is 20 cm cube. Yep, 20 cm cube. Okay, but we need to change the unit to dm cube. Okay. Okay, 1 dm cube equals to 1000 cm cube. Okay. So, like this. Okay. Should be, should be 0.05. Yes. 0.05 mole per dm cube. Okay. Mole per dm cube. Okay. So this one, next step, we want to change mole per dm cube to gram per dm cube. So we want to change mole to gram. Okay, we want to change mole to gram. Okay, we know mole equal to mass divided by mR. So this is the mass. Okay, so if we want mass, we need to take mole multiply mR. Yeah, okay. So the mass of the sulfuric acid will be mole, which is 0.05. How about the mR? Okay, mR of sulfuric acid is it given? No. Okay, we need to calculate by ourselves. mR of sulfuric acid, okay, is 2 hydrogen plus 1 sulfur, okay, and then plus 4 oxygen. Oxygen is 16. Okay, sulfur, we will check. Let's check. Sulfur is here. Sulfur, the mass is 32. Okay, sulfur is 32. Okay, hold on. S 32. 2 plus 32 plus 64. Okay, so that should give us 98. Okay, okay, so 0.05 multiply the mR, 98, so that will give us 4.9. Okay, so which means this one 0.05 mole per dm cube is equivalent to 4.9 grams per dm cube of sulfuric acid. Okay, so that's the idea for this question. Okay, yep, 4.9 gram per dm cube. Okay, cool. So the rest, which is organic chemistry, so we haven't learned yet. We will skip for now. Okay. Yep. Okay, this is done. So the timing is also perfect. Okay, before we go, let us just quickly okay, actually I will send some practice questions also. Yeah. Later I will send some practice questions for you to go through on your own as well. Okay. Wait. Okay. Okay, before we go, um, hmm, yep. Okay. So this is our calendar here. Okay. So we are at here. Okay. So we are at here. So according to our plan, we have one class here next Tuesday, and then this is 1st of January. This is 2nd of January. Suppose we also have one more here. Okay, so if no other changes, we will have another 2 more class in next week. But if you want any changes, you have something to do, then we can also change it. No problem. Okay, just let me know. Okay, so if no other question, we will stop here. See you on next Tuesday. Okay. All right. Thank you.
Okay.
Thank you. Bye
Bye.
bye. Bye bye.